The previous few days in class, we've been talking a lot about how do we take measurements like we did on day one and record them to the proper amount of precision. We then moved into sig figs and said, well, within a measurement or within a value provided to you into this class, how do you know which digits are significant or measured values? And how much do we report those calculated values or measured values to? Now what we're going to do is we're going to move to our last way that you might see reported measurements or counted values in this course. Sometimes in chemistry, we deal with really big values. We work with subatomic particles, for instance, and we work across large distances. And so if we have really small things and really big things that we work with in the class, how do we show those numbers in a written value? What is the most efficient way that we can express how large or how small something is? So for example, if we're thinking about the Milky Way galaxy, this is the galaxy that we live in. That Milky Way galaxy is about 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 and so on kilometers from one edge to the other. So it's a really big place. That's a whole lot of zeros to write down. This number here, this 602 number, this is the number of particles that are in what we call mole of a substance. This is called Avogadro's number. We'll be exploring it more second semester. This is a really large number of particles that we group together into something called a mole. So since we work with really small things and we have to count them in large groups, or we work over large distances in some cases in some branches of science, we use something called scientific notation to make our lives easier and to report these values more efficiently. So what we've given you is we've given you two tables here. One side of the table has our numbers in what we call the scientific notation form. Scientific notation has two parts. The first part is a number. This number is typically between, if you look at the pattern here, between these two values, 1 and 10. So that means that your number that goes in front of the times 10 to the part that you're seeing here can't be less than 1, and it can't be more than 10. So something from like 1 point something to 9.999 would be acceptable, right? That is our first rule. The second thing is you'll notice that there is this certain power of 10 here, okay? Now, on the top value, this power of 10 is -2. What we can see is we can see the corresponding what we call standard form number. This is the normal way you would see the number written. This is here to the left. This is also called either expanded decimal form or decimal form number. So this number to the left in the yellow column is the same as this number to the right. And the same goes on this row here as well. This 8.317 times 10 to the 6 number is the same as 8,317,000. So the question here is, how do we get between these one form to the other? And how do we know what kind of exponent we write when we're writing in scientific notation? So one other pattern that I hope you can notice is that this exponent or power of 10 indicates how many places the decimal has been moved as you move from the scientific notation to the standard form number. So for instance, if we look at this first guy, let's write down this pattern. The power of 10 used indicates how many places the decimal has moved. Okay. So if I look here and I look at 0.0103, right? How did I get to this scientific notation form? Well, it looks like to get to this 1.03 number, this first number, we had to move the decimal place 2 spots to put it between the 1 and the 0. Okay. Now, when we record the exponent number, what we notice is for this particular value, the exponent number is negative. Negative exponent value numbers are used for numbers that are small. Okay, less than 1, the exponent value is going to be negative. So because we moved this 2 places, and because this expanded decimal form number is smaller than 1, we're going to make this exponent sign on this value be negative 2. Now, if we take a look at this guy, 8.317 times 10 to the 6, its corresponding standard form or expanded decimal number is really, really large. It's 8,317,000. So what do we think? When we put this into scientific notation, we notice that this exponent sign is positive. So for a positive exponent, what you should see as a pattern is the corresponding standard form number is very large. So how do we get the 6 and how do we get that piece of the exponent? Well, to go from this value to this value, right? If I want to move this to make it 8.317, to put it in the first number between 1 and 10 in scientific, our decimal right now is hidden behind those zeros. So if you ever see a number with ending in zeros, there's a hidden decimal there. What we did to get into our scientific form is we essentially moved this decimal 1, 2, 3, 4, 5, 6 spots to go between the 8 and the 3. That puts our first value between 1 and 10. We know that the exponent value is 6 because that's the number of hops we took. But then how do we know if it's a positive or negative exponent? Well, this standard form number is really large. Okay, it's a big number. So that's going to give us a positive exponent, and we're going to keep it like that. Okay? So our third pattern that we should notice is that if the standard form number is large, and by large, I really just mean greater than 1. Okay. The exponent is positive, like we see in this particular example here. Correspondingly, right, if the standard form number is small, right, like we saw on that first guy, 0.0103, the exponent is going to be negative. Okay, that gets us our 3 general rules or patterns that we should have seen through this guy here. Now, one thing that I'll give you as a pro tip is we're going to practice how do we do this in our calculator, and we're going to practice how do we go between scientific notation and standard form. I was just going over the general patterns here. One thing that you should always just note as a general rule is that your decimal point, when you put this into scientific notation from standard form, should go immediately after the first digit in scientific notation. So meaning the first non-zero digit, that's typically where the decimal goes. So in this case, it would go after the 1 when you put into scientific. In this case, it goes after the 8. One thing, we talked about sig figs. All numbers in front of the times 10 to the part are always significant. Okay, so for instance, this 9.512 times 10 to the negative 8th has 4 sig figs. These two here would also be significant, 8 and the 0. This is a 0, trailing 0 in a decimal number, meaning it's a significant 0. We do not count the times 10 to the part in our sig figs.
All right, let's do some practice problems, and then we will let you check your answers by giving you a little pause in this video. So the first practice problem, we're going to be converting each of these decimal form numbers into scientific notation. So on the side here, I have a series of steps that I take every time I approach a problem, and it's kind of modeling how I'd use the charts above that I showed you. So the first thing is that I notice I'm in decimal form, And one of the things I'm going to do is I'm going to look, okay, which way am I going to have to move my decimal? Okay. So over here, I know that I have to move my decimal to the right, putting it between the 3, 5, and the 6. Okay, so I know my first number should be 3.56. Now what I'm going to do is I am going to look at if I'm positive or minus. So that means that I can look at what I have up here in my charts. So I know that if I'm in decimal form and I want to go into scientific notation, if my number is less than 1 in decimal form, that means the sign in front of my exponent is going to be negative. So looking at this number, I do see that it is indeed less than 1, which means that I am going to go ahead and put a negative here. Okay, so that's going to be a negative number. Now, how many hops did I take to get my new decimal? I'm going to go 1, 2, 3, 4. That means I made 4 hops, which means that my new number here is going to be to the negative 4th power. Okay. So that is number 1. Let's do number 2 together, and then I will let you have some time in this video to try one on your own and check your answer. All right, so this next one, I notice which way am I going to move my decimal. I'm going to move it to the left, so I can put it between the 1 and the 4 to make my first number between 1 and 10. Then what I'm going to do is I'm going to write down all of this digits afterwards for now. So 1.445, and we're just going to stop at this decimal for now. We're going to learn that these zeros are what are called insignificant zeros or placeholders. More on that later, okay? So don't include them for now. So that's 1.445 times 10 to the something. So what I need to figure out now is if this is going to be plus or minus. Well, I notice that this number is much bigger than 10 in decimal form. And so what that means is that this is going to end up being a positive exponent. So how many places do I have to move this decimal? Well, I started at the end here and I went 1, 2, 3, 4, 5, 6. So this is going to be times 10 to the 6th. Go ahead and try number 3 and number 4 on your own and come back when you are ready to check your answers. So pause this video. All right, we're welcome back. This answer should be 9.8 times 10 to the negative 3. So again, the reason why is we're going to put our decimal between the 9 and the 8. Which way did we go? We went to the right to move that there. All right, so that's how I know I had to go to the 9 and the 8. Is this plus or minus? Well, this number is less than 1, meaning it's going to be a negative exponent. Whoop. And then finally, we had to move 1, 2, 3 hops there, so that's why it's a negative 3 exponent. 7.906, you might have noticed something a little strange about this. It is already between the numbers 1 and 10, which is what we need for our first number for scientific notation. So for this, we're actually just going to write 7.906, and we want to keep this the same, okay? So if the number is already between 1 and 10, what we're going to do is we're going to put the sign or the exponent itself just to be 0. So I'm just going to multiply 7.906 times 10 to the 0. Because 10 to the 0, this just equals 1. So that just keeps the number the same. So if the number is already between 1 and 10, we don't need to really mess with it too much. Just multiply it by 10 to the 0 because we're already between 1 and 10. Okay, so for this rule up here, this decimal form number is already between 1 and 10, so it's 0. That's what our exponent would be. All right, let's convert to decimal form. So for this one we follow the exponent. Okay, so I'm going to write this 1.03 over here to give us some more room. So I see that is a negative 2. When I have a negative exponent, I go to the left. So let's move that decimal to the left. 1, 2 spots, open cradle, put the decimal after the last cradle. So this new number is 0.0103. Let's look at the next one. The next one is 8.317 times 10 to the 6th. Okay, so for this one, what we're going to do is I see a positive exponent. Positive exponent means we go to the right with our decimal. So 8.317. We're going to go 1, 2, 3, 4, 5, 6. 3 open cradles. Decimals at the after the last cradle. So this new number will be 8317123 zeros. All right, you go ahead and try, and then I'm going to post the answers to these ones after you're done trying. So pause this video and give it a go. So these were really big numbers, and so I hope this wasn't too crazy. Notice both of these are to the -8th power, so we're going to go to the left with these decimals. So what I would do if you're doing a homework, I would move your number all the way to the right to give yourself some space and start counting those cradles. So we're going to move to the left 8 spaces or 8 hops. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Then fill your empty cradles. And there we go. That is our new number. Okay. So it is a very, very, very small number. I can erase the cradles so you guys can see it more clearly. All right. Same thing over here. Same deal. When you do this, you can try this one on your own. This one will come out to be 1, 2, 3, 4, 5, 6, 7, 7, 5. Woo! That is a big one. All right, the last thing I'm going to show you in this video is how to use your calculator and how I would go ahead plugging things into your calculator in my class. In my class, you can use 2 different styles of calculator. You can use what's called the TI-30X, which is a triangle head. It's by Texas Instruments. It's pretty cheap on Amazon. And then there's also a TI-84. So any graphing calculator you might use for your math class, you can use in my class. So whether you're using either of these, when we're plugging things in when scientific notation on our calculator, it's really, really important that we utilize the right functions. So I'm going to pull up my own scientific calculator here. And so when you're typing into a calculator, you might feel really tempted to use this times 10 caret sort of function. But what we're going to do in my class is we're not going to use the times 10 button. Okay. This just screws up our order of operations. So we are going to use what's called the EE button. So this is basically a substitute for times 10 to the in scientific notation form. So for this one, it says if I want to put 5.07 times 10 to the 9th into my calculator, the way I can plug it in, at least on a TI-84, is I can go 5.07. So that's my first number between 1 and 10. And instead of doing times 10 to the, I am going to press the EE button. So on the TI-84, the button is second, and you're going to press the comma button, and you should see some sort of E appear, whether it's uppercase or lowercase. In my case, it's going to turn uppercase once I put the exponent name in, and then I'm immediately going to follow that with my number of my exponent. In this case, it's 9. So this 5.07 E9 means the exact same thing as this. Okay, so wherever you see E, that's just saying times 10 to the. Okay, so again, on the TI-84, that's what it looks like. On the TI-30X, make sure you're pressing the X to the -1 button. Okay, so second X to the -1, and you should see something similar. All right, so for number 11, I'm going to show you how to do this. And then the last tip before we do number 11 is to always use parentheses. So on my examples here, you're going to see parentheses around everything. I suggest whenever you put a number into scientific notation that you put some parentheses around it. Okay. So here we go. 1.46 times 10 to the 5th. I'm going to do this example with you, and then I will let you guys try the rest on your own for home fun. And I will put it at the end of this video in case you want to look at it after I pause. Okay. So for 11, 1.46 times 10 to the 5th divided by 1.46 times 10 to the 7th. What you can go ahead and do is let's throw that into parentheses. So I'm going to go 1.46. Second, comma, 5, close the parentheses or else you're going to get a syntax error. Whenever you see a slash, that means divide. Okay, so on this calculator, it even shows it as a slash as well. And then I'm going to plug in my other number. So we're going to go second, E7, and boom. That spits out the number of 0.01, which is what you should get if you plugged in your answer or your numbers correctly. So here it says to put your answer in scientific notation, which is something I'll ask you to do on future homework assignments. So 0.01, Okay, I see that that number in decimal form is less than 1, which means that my exponent should be negative. So I want my new decimal to be after the 1 here. So it's just going to be 1 times 10. And how many hops did that take? 1, 2. Since my number is less than 1, it's going to be a negative exponent. We're going to go negative 2. All right. Cool. I'm going to skip down and actually show you 13. This is really, really important. On your calculators, when you plug something like this in, what I want to make sure that you do is you actually utilize the negative function instead of the minus function. So for this one, 9 times 10 to the negative 1, you would plug that in as normal to begin with. So 9 EE, so EE button. And instead of doing a minus sign, you might be tempted to use a minus sign. You should look on your calculator for your negative sign in parentheses, which is usually towards the bottom near the enter button. And you should enter the negative 1 that way. Okay. Then you're going to multiply that by the next number. So 3 second EE 10. Notice how there's no tens. There's no multiplication signs within the scientific notation. And then you should get that answer of 2.7 E10, which just means the same as 2.7 times 10 to the 10th. All right. So for the other ones, I'm going to pause here, and then I'm just going to go over what the answers are and see if you got it right. All right, so if you did this correctly, this one should have come out to be 2.4675 times 10 to the 23rd. Now, that's a lot of digits. We'll learn in the significant figures lesson what to do with those digits and where to cut off and round them. And for this one, we should have gotten 8.39 times 10 to the 3rd. Hope this was helpful. Thank you very much. See you guys later.